paper, we have 10 questions that we shall be looking at and we shall be exploring, okay? So with question number 1, which is the multiple choice, they're telling us that we have 4 options and we must choose the most correct option. Now we have 3 forces that are acting, okay, on an object as shown, so that the resultant force is what? 0. So each of the following vector diagrams is correct representation. So if I'm to look at this with the format of the vector diagrams, which is the head to tail, A cannot be, C cannot be. But when I look at D and B, there could be something there. An example, if this one starts from here and goes up, this one goes down, this could be the resultant. Okay, so if this one, then that. So I'm gonna take B to be my correct answer for this case, okay? I'm taking B to be my answer. Please, you help us in the comment section if you differ with what we are choosing, okay? 1.2, we have 2 large objects P and R, each with mass M, and placed between the centers R meters apart. They exert a gravitational force, which is M. So we know that the formula for the gravitational force is G, mass 1, mass 2, over R squared. But then they're telling us that the mass of the second one is being increased by 2, or is increased to 2m, okay? So you're gonna have a 2m, which is like a times 2 there. And then the distance is now increased to 2r, okay? So meaning that we're gonna have G, M, and M. Let me call this M1, M2, but it is 2 times. Over, now when I get the 2r and I square it, I'll get 4r squared. When I simplify this, we're gonna get a half. So that's gonna be a half G M1, M2 over R squared, of which this represents our force. So my option will be for that case. Then 1.3, the velocity versus time graph sketched below for the motion of a ball that's projected vertically upwards, top of a building. Okay, so it was thrown upwards, okay, with a certain velocity. It reaches the maximum height above the ground, and then it hits the ground and then bounces off and then reaches the maximum height again, another height. So we know that S is always smaller than Q, okay? Because at this point, the velocities are 0, which means those are like maximum points. It's more like bouncing because of the amount of energy. The energy at Q is greater than the energy at S. So the ball reaches highest height above the ground at a certain time. Which point of the graph corresponds that? So I'm going with Q, okay? That's 1.3. And then 2 hard objects collide inelastically in an isolated system. Which of the following sets of statements will be correct? So both total momentum and kinetic be conserved? No, we know that momentum will always be conserved regardless. But when it comes to the kinetic energy, for as long as it is inelastic, kinetic energy will not be conserved. So neither total, this is wrong. Total momentum is not conserved, that's wrong. So option D is the best. So total momentum is conserved, but the total kinetic energy is not. Then 1.5, we have an engine P, which has a greater maximum power output than engine Q. Which of the following is correct when P and Q operate at their maximum output? Now, the fact that P is having a greater maximum power, it simply means that it can finish the work within the shortest time possible, for as long as the work to be done is basically the same, okay? So if the work done is not the same, which means that P can do greater work compared to Q, if the time varies. Okay, so they're telling us Q does more work than P in the same time. Q has a smaller output, so it cannot be. Then we're saying that P and Q do the same amount of work at the same time. This is wrong. P and Q do not do the same work, but Q does it in a short, no, it cannot be a shorter time for Q. It's a shorter time for P. P and Q do the same amount of work, which is correct, but P does it in a shorter time. Option D is the best. 1.6, we have the absorption spectra of the same elements surrounding both star A and star B as observed from the Earth. The spectral lines from star B are more redshifted than those of star A. So how do the frequencies compare? So with 1.6, I'll go with C, because the frequencies observed from B will be lower because the wavelength is higher. And then the speed is going to be greater. Okay, then 1.7, telling us R and S are two small charged spheres. Okay, we don't know what's happening here. So when I look at R, okay, because they gave us the net electric fields. This is R, and then this is the electric field due to R. Since the direction is in that sort, which means there's a repulsion. And we know that P is a positive point charge. Okay, so if that's a positive, this one must also be a positive. And then when I look at S and that, it's moving this direction. So meaning that S must also be moving that direction, which is attraction, okay? So that is gonna be a negative. Okay. So if S is a negative and R is a positive, which option do we have in that case? So it's saying R is positive, S is negative. So option A is what I'm going with. Then 1.8, the circuit below was used in a practical investigation. There's an EMF and internal resistance. We must ignore the connecting wires, okay? So we have graphs K and L below as obtained. So we have an adjustable resistor, which we know I call a rheostat. So we're saying that voltage against current, we have graph K, which obeys Ohm's law. And then this one does not obey Ohm's law. Now, the fact that this is a standard graph, okay? And we know that with the rheostat, what happens with the resistor, with the resistance, it's not constant, it keeps on changing. Eh? So meaning that the voltage V2 should give us, or should represent the Ohm's law. And then the voltage V1 must be represented by the graph L. That's my understanding of this. So V1 is L, and then V2 is K. So K is V2, and then V1. So I'll go with C. I don't know what the masses have to say about that. 1.9, which one of the following is the function of the split ring commutator in an electric motor? So mainly it's to change the direction, okay, of the current. So ensures that the current in the external circuit changes direction. So option D would be the best then. And then 1.10, which one of the following statements correctly describes the photoelectric effect? So with this, I'm choosing option C, that an electron will absorb the energy of a photon and is ejected from the metal surface, okay, if the energy is indeed sufficient. Okay, so that is to do with question number 1. Question number 2. There's a crate of mass 25 kilograms that slides down a rough inclined plane, okay, at a constant speed of 2 meters per second towards point A. Okay, there's a force F that acts on it parallel to the incline as shown. There's a constant kinetic force, 40 newtons, and the incline is 30 degrees. Now they want us to state Newton's first law of motion in words. So this law simply tells us it's also the same as the law of what? Inertia. So what does the law of inertia state? That a body remains at rest. It's fine, let me write it this side. So this is 2.1. 2.1, they're telling us that a body remains at rest. Okay, a body remains at rest or constant motion or speed in a straight line, unless acted upon by a resultant force, call it the resultant force, or we can call it an external force. So unless we have something extra that is acting on it, we expect the body to continue moving in the same direction or resting the way it is, okay? Then at 2.2, they want us to draw the free body diagram showing all the forces acting on the crate as it moves towards B. So what we can see is that there is this force F that is acting in that direction. Okay, but since the crate is moving downwards towards A, we're going to have the friction force. The frictional force is also going to act in that direction. I'll say F friction. We call it Fk. Yeah, let me call it Fk. And then now we're going to have the weight downwards, and then we're going to have the normal force upwards. We can have the Fg parallel here if we wish, but we already have enough forces for what they wanted. So 1, 2, 3, and 4 is enough for the 4 marks. Then 2.3, they want us to calculate the magnitude of F, which is the applied force for 3 marks. So you can use Newton's second law, whereby we know that the F net should give us the MA. Now down the incline, we know that we have the Fg parallel. We say the frictional force is going to be acting upwards. So if I get my Fg parallel plus the Fk plus the F applied must give me the mass and then the acceleration. So my Fg parallel is mg, the sine of theta. My Fk was a 40. I will say negative 40. The F is acting in the opposite direction, which will also be a negative F, will be equivalent to 0 because the body is moving at a constant speed, which means there is 0 acceleration. Let me substitute. The mass is 25 times 9,8 multiplied by the sine of 30. Now I'm subtracting 40. I should move the force applied that side. When I punch this into the machine, which is the calculator, okay, I'm ending up with a nice answer of 82.5 newtons. Okay, so this is our applied force as required by the question. Please just confirm with that. If I'm having the same, so we're saying sine of 30, and then we subtract a 40, 82.5. Perfect. Then we move on to the next question. And then they're telling us that when the crate reaches point A, it starts to act up, okay? The force F is removed, and then the angle of inclination decreases immediately to a certain angle, which is theta, so that the crate continues moving at the same speed. So we're maintaining the speed of 2 meters per second, but with a difference within the angle and then within the forces that are there. Now, for us to answer this, because now we're seeing this kind of scenario, then they're asking us to use the relationship between the forces that are acting on the crate between point A and point B to show that the mu k, okay, the correlation coefficient, the coefficient of friction is given as this, okay? Now, if the force F is removed, which means we are only left with the frictional force and the Fg parallel that will be acting downwards. So that's what I'm going to use here and say that we can still say that F net is equal to 0 because it's still moving at the same speed, and then Fg parallel is going to be mg, sine of theta is equivalent to, we know that frictional force is given as the mu k multiplied by the normal force. Let me just start by that, Fn. Then this is mg sine of theta. We know that it's going to be the mu k over the normal force, but normal force is given as the mg cos of theta. So I'll say over mg cos of theta. So the mg and the mg will cancel out, meaning that the mu k will be the sine of theta over the cos of theta. Okay. Then 2.5, they want us to get the, no, they're telling us that the coefficient of kinetic friction between the crate and the plane is 0.19. They want us to use this identity from Trig. Oh Lord, why must maths always haunt us? Okay, let's use this identity, okay, to calculate the frictional force as the crate moves from point A up to point B. Now, one thing we need to know is that we know that sine of theta over cos of theta must give us the tan of theta. But we said this is representing the correlation coefficient. So what is that going to be? I'm going to say, let me change this around and say that the tan of theta is equivalent to 0.19. So let me get the theta, which is the shift tan of 0.19. Okay, so shift tan of 0.19, that gives me 10.76. Okay, degrees. So this is the new angle, okay, that we're dealing with. Now the question wants the frictional force. Then we shall go down and say that our frictional force, Fk, is given as the mu k multiplied by the Fn. That's gonna be the mu k, which is the 0.19 multiplied by the mg cos theta. I'm using this, but there is also another way to do that, okay? The mass is 25, and then the 9.8, then we're saying the cos of 10.76. When we punch this, yeah, I'm getting a 45.73 newtons. Alternatively, somebody would have used, there's another approach that one could have used. And that is to say that this FG parallel is equal to this. Okay, and you just say that the mass times the gravity multiplied by the sine of theta. So that's a 25 multiplied by 9.8, and then the sine of 10.76. Let me just confirm and see. So 25 times 9.8, and then the sine of 10.76. Perfect. I'm getting a 45.7. Oh, yeah, just the difference of a 0.01, which is not bad. Okay, so either way, you'll always get the same thing. Then question number 3, I'm telling us that there's a ball that is dropped from point A and reaches point B, which is h meters below A in time t. The ball takes a further 2 seconds to fall from B up to C. The distance between B and C is 8 h meters, 8 times the original height. We are ignoring friction as always. Then they want us to define what free fall is. So free fall is just a motion. Okay, it's a motion of an object. It's motion of an object that is under the influence, okay, under the influence of only the acceleration due to gravity, or it's just under the influence of the gravitational force. Okay, then 3.2 show by means calculations that t is a 1 second. Perfect. I love such questions where they even give us answers. No? We can never go wrong there. Okay, so for us to show that, I'll have this as my displacement. Okay, so I'm going to use the second equation of motion, okay, which says delta y should be v initial multiplied by delta t plus a half g delta t squared. Okay, so h is going to be, our initial is 0 since the ball was just dropped. So it's going to be a half times 9.8 t squared. I'll call this equation 1. Okay. So if this was a t and this was a 2, okay, let me look at the, I don't know, should I look at the entire journey or just this other section of B? I can look at the B part, né? And say that still using the same formula, 8h is going to be still a half, but then that is going to be tricky for me. Let me use the total distance, which is going to be now 9h, because 1h and 8h is 9h. Then this is times 9.8 into a t plus 2, and then I square that. So where there is h, I'll replace with that. So this is equation 2. And then I'll say that I'm substituting 2 into, no, I'm substituting 1 into 2. Okay, so it's going to be 9 into a half times 9.8 t squared is equivalent to a half multiplied by 9.8. I'll have t plus 2 squared. So half 9.8, half 9.8 dies out. I have 9t squared is equal to, that's going to be t squared plus 4t plus 4-ish. Now we have quadratics here. Okay, let's collect the like terms and let's create the standard equation. So that's going to be 8t squared minus 4t minus 4 is equal to 0. Divide through by 4. So t squared minus t. And then we have minus 1 is equal to 0. Then let's vector this out. Okay. So when we are factoring this out, we're going to have a 2t. And then we're going to have a t. This can be a minus 1. This is going to be a plus 1 is equal to 0. So the first bracket, t is negative a half. We can never have time as negative. And then t is a 1. So this is what the question wanted. So this is how I would have worked this out, okay? So if you have a better way, a quicker way, shorter way, please just help us, okay? Then 3.3. And they want us to use just the equations of motion only to calculate the speed with which the ball reached point C. So with this one, there's just a short and quicker way. Let's use the first equation of motion. V final is equal to V initial plus G delta T, since it's free fall, okay? Our initial is 0, meaning that V final is going to be 9.8 multiplied by the total time, because T is 1. So it's 1 plus 2, which is a 3. And then this becomes a 29, okay, 4 meters per second. That's what we do. This is the shortest, okay? The other alternative is by you going through the displacement approach and you use the VF squared is equal to VI squared plus 2G delta Y. Okay, you can also use this, but you'll have to find the total displacement first, okay? After getting your T as 1, you can go back and substitute and find the H and then, but this is a longer way, okay? Because that's what actually question 3.4 requires. That determine the height from which the ball was dropped, the total distance. So since we know that our H was given as what from one of the equations, we said a half times 9.8 t squared, okay? So a half times 9.8 t squared, meaning that's a half multiplied by, no, this is 4.9 t squared, where the t is 1, then the distance is going to be 4.9 meters. But this is just the height, h. Then the total height, okay? Total height is going to be 9 times, which is going to be 9 multiplied by 4.9. Okay, 9 times, we say 9 times 4.9, I'm getting, we said 4.9. I'm getting 44.1 meters, okay? Any alternative is also acceptable, okay? That is how I would have answered 3.4.1 for 2 marks. Then they want us to get the height. Is that the question? Okay, the height of the ball at B. Yes. Now at B, remember the total distance is 44.1. Okay. Now what is 44.1 minus 1h? Remember we say that 1h is what? Just 4.9. Okay, we are subtracting a 4.9. That gives me 39.2 meters. There we go. Okay. 3.5, they want us to sketch the graph. Okay, I'll just squeeze it here, guys. Yeah? Sketch a position versus time graph, motion where the ground is the 0 position. Okay, so if that is the ground as our 0 position. Okay, this ball was projected up. What do they mean by that? So ground is the 0 position. If you go up, it's positive, which means the body moved in the negative direction forwards. Okay, so it's possible for us to have something like that. where this is going to be our 44,1. And then the object moves up to that point. So this is the C point. And then we can have our 39,2. The 39,2 comes after. Isn't that too far? Isn't that too far? Let's change it and say if this is 1, 2, and 3. So just this point here, which is the 39,2. And then this is going to be the point B, which is 1 second, 2 seconds, and 3 seconds. So this is the time in seconds. This is going to be the position in meters, or the Y in meters. Okay, we can have it like this, or somebody would have drawn it like this, and then you indicate this kind of thing. Okay? So that is your B, this is your A, and then that is your C. Okay, so something of that nature, this or that. Then question number 4. We have a trolley A of mass 1,5 is resting horizontally on a frictionless surface. The second trolley B of mass 2 kg travels horizontally at constant speed V and collides with A. Trolleys stick together and move at a constant velocity to the right. Okay, this one is resting, right? Right. Okay. There's a distance covered in 2 seconds. Okay, state the principle of conservation of linear momentum. So we know that in an isolated system, we're going to say question 4.1. Okay, in an isolated system, the total linear momentum is conserved. Okay, so that's what you have to say. In an isolated system, the linear momentum is conserved or remains constant. And then 4.2, what do they want? They want us to calculate the speed V with which B moves before the collision. So let me summarize this nicely, and we've seen that if we have A, we have B. What are the masses? We know that the mass of A is 1,5. The mass of B is 2. The velocity initial for A is 0 since it's resting. This one velocity initial is just a V. Okay, we know that the velocity final and the velocity final is just the same. Now, they want us to calculate the velocity V, this one. But we can get our velocity final first, because we know that the velocity final will be the displacement over the change in time, which was 0,8 over 2, meaning that our final velocity is 0,4 meters per second. Then we apply the conservation of momentum. We know that mass A, initial velocity of A, plus the mass of B, initial velocity of B must give us the mass of A, the final velocity of A. Okay, since it is now one system, let me just combine everything at once and say plus mass of B into V final. Okay. Now, initially, this is going to be 1,5 multiplied by 0. This is 2 multiplied by V is equal to 1,5 plus 2 multiplied by 0,4. Going to have a 2V being equivalent. Okay. That's going to be 3,5 multiplied by 0,4. I'm getting a 1,4. And then V becomes 0,7 meters per second. Okay, so that is 4.2 that the question wanted. Then 4.3 is the collision elastic or inelastic. So without a doubt, this is, I did not say inelastic. I said inelastic. Okay, it's inelastic. Why? Remember, there is no energy within trolley A. Okay, but the energy of B initially and the energy of the combined system after cannot be the same. Energy is going to be lost, okay, in one way or the other, given the fact that the final velocities or the velocities are not maintained. This is a 0,7, which is higher. The final is 0,4, which is lower. So there was energy that was lost. So that is inelastic. We don't have to prove or give a reason. Then 4.4. they are telling us that during another collision, okay, so if there's another collision, trolley B exerts a greater force on trolley A, and the change in momentum just stays the same, okay? How is the time for the collision affected? Choose increase or decrease. So in this case, I'm going to say decrease, or because the change in time is going to be shorter. And then they want us to write down a relevant equation to support the answer. So we know that force multiplied by delta T should give us the change in what? Momentum, the impulse. Then we're saying that delta T is the same as the change in momentum over the force. So remember, the change in momentum is the same for both, whether A to B or B to A. So if that is the same, if the force is greater, the time must be smaller, because time is inversely proportional to the force. Okay, so this decrease and this formula is perfect enough. That is 4.4 and question 4 as a whole. Then question 5, there is water that is drawn from a water source that is 12.5 meters below the ground by an electric pump. The water is lifted vertically upwards at a constant speed as shown in the diagram. Okay. Then they want us to define the term and conservative force. So we know that this is a force, okay, in which the work done by the force is dependent. Why can't I say the work done by the force depends on the path taken? Okay, on the path taken between any 2 points. Then they want us to draw a free body diagram showing all the forces acting on a fixed mass of water as it moves from the source to the ground. Okay, so if a fixed mass of water, let's say it's somewhere there, this water is gonna experience what we call the weight. Okay, is there any other force that is gonna act on this water? Not really. I don't think there's any other force unless if. But the other one that I could think of is the fact that the water is going upwards. There should be the force by the pump. Okay, force by the pump. So meaning that we're gonna have the force pressure by the pump, and then we're gonna have the weight downwards for 2 marks. It's reasonable. As much as we might have friction by the pipes and what, but that is usually because they told us to ignore the friction and capillary effects. So if there's no capillary effects, which means it's just the force by the pump and then the weight that's acting downwards. But since the pump is greater, then the water will go up. Then 5.3, because they told us that the pump lifts the water at this rate. The pump lifts 200 kilograms of water from the source to the ground at a constant speed. Calculate the work done by the pump. Okay, so we know that the work done is going to be the mass multiplied by the gravity multiplied by, so it's more like the gravitational pull, okay, which is going to be the mass, which is 200 multiplied by 9.8 times the 12.5. So this gives us 24,500 joules. Okay. Then they want the constant speed at which the water is lifted. Constant speed at which the water is lifted. Let me jot it this side. So it's the 5.3.2. So it's a tricky question. 5.3.2. So if we are lifting 200 kilograms at basically 2.5 kilograms every second. Okay, so this is 2.5 kilograms in 1 second. How about the 200 kilograms? How many seconds are we going to need? So let's just divide this. So 200 over 2.5. This gives us let's just confirm that, please. Let's double check. Okay, so we're saying 200 divided by 2.5, which gives me 80 seconds. So it's gonna take 80 seconds to move 200 kilograms of water. Now, for me to get my velocity, okay, I'll get the displacement, okay? I'll say delta y over delta t. Now my delta y, the distance through which the water is gonna move, is 12,5. The delta t is gonna be 80 seconds. Then 12,5 divided by 80 gives me 0,156, which is approximately 0,16 meters per second. Okay, so that is the velocity that the question is asking for 3 marks. Then 5.3, they want the average power that is dissipated by the pump. So for average power, I can as well get the work done divided by the delta T. So the 24,500 divided by the delta T, which is 80. Wow, it was a tricky question, but I believe it was a doable work energy kind of question. So that is 306,25 watts for the power. Okay, so that is question number 5. Then question number 6 are telling us that there is a bat that emits sound waves with a frequency fs as it flies at a constant speed vv towards a vertical cliff. Okay. Then the waves reflect off the cliff with the same frequency that they strike the cliff and with the wavelength of this much as shown the simplified word. So the bat is moving. The bat emits with a frequency as it flies at a constant speed. So if the speed of sound in air is that, okay, name and state the phenomenon. So that phenomenon is what we call Doppler effect, okay? And then we just have to state Doppler effect because we know that this is the apparent change in the observed frequency, okay? And the reason as to why there is a change in the observed frequencies compared to the frequency of the source is as a result of the change within the velocities of the sound source as well as the listener, okay? Difference in the velocities of the listener and the sound source. So that statement of Doppler effect should be well stated. Then 6.2, they want us to show that the frequency or the frequency of the source is given as this. So what we need to do is that we need to start by finding the frequency of the listener. We know that V is equal to F lambda. So we know that that's going to be V over lambda. We know that our V is 340. And then our lambda that we're given was 0,016. If you divide that, that is number 1. Now, if this is true, we can go to the Doppler formula, okay, and substitute. Okay, so then I'll go back to the Doppler formula. Let's see, let me put it here and say that frequency of the listener should be equivalent to V, okay. I'll say velocity of the listener over V. I'll say minus. This is going to be velocity of the source multiplied by the frequency of the source. Now, we know that the bat is the source in this case, and it's also going to be the listener. So let's take it to be moving in this case. So our FL that we got was 21250 is equivalent to 340 plus, if the listener is stationary, that's going to be a 0 over our 340 minus VB multiplied by the frequency of the source. Now remember, we're looking for the frequency of the source. Okay, then I'm just going to multiply through. So I have my 340 minus VB multiplied by 250 is equivalent to 340 Fs. But let's divide through by 340. I don't want to open those brackets. So 21250 Divide by 340 gives me 62.5. Okay, that's 62.5. We have 340 minus 50 is equal to frequency of the source. Then when I open this up, meaning that this 340 cancels that, is going to give me 21250 minus 62.5 VB. So that's the frequency of the source that the question technically wanted. Okay. Then next, 6.3. They're telling us that the frequency of the reflected sound detected by the bat. Now, if it is detected by the bat is now the listener. Okay, which means the frequency of the listener is 850 higher plus the frequency of the sound waves emitted. Okay, so it's 850 plus the frequency of the source, which is going to be 850 plus this whole thing or this whole scenario. So what does that give us? Okay, let's go down again. We're still using Doppler, the formula for Doppler. So this is 6.3. Okay, 6.3. So we shall say that V plus VB over V minus VB must give us, I'm just gonna say frequency. Okay, I'll just put the simplified version of it that I'm having 1, okay, plus 850 over Fs, technically. Okay, so when I substitute, I have 340 plus VB over 340 minus VB is equivalent to 1, plus the 850 over Fs. And then we know that our Fs was that 2, let me just replace it now, and say that 21250 minus VB. Okay, so what do we do next? Just have to simplify this. Okay, let me simplify. So 340 plus VB over 340 minus VB. Cross multiply, we're gonna have 21250 minus VB plus 850 divided by 21250 minus VB. Okay, I have a whole lot of VBs now. Yep. Okay, 340 plus VB is giving me, what's 21250 plus 850, that is 2200 minus VB. This is gonna be 340 minus VB. And then this is what are we doing? Okay, that is fine. This is 21250 minus VB. We're multiplying it by that. Okay, so when I punch this into my calculators, it's huge. 21250 times 340 is giving me 7225000 plus 21250 VB minus 340 VB and then minus VB squared. I must do the same thing here. Okay. 340 times 100 is giving me 7514,000 minus VB squared plus 22100 times 340 We're done with that. We're looking at the VB now. It's going to be 22100 VB plus VB squared. Okay, so meaning that this is gonna, oh, it's not gonna cancel. Only one that is canceling is this one. Wait a minute. Why am I having? What am I doing? Hello. That is that. No, I think I'm messing up somewhere here. I'm doing a mess here. Okay, 340 on this, we get that. 340 on that, we have negative 340 VB. Okay, this and that is negative 2 to 100 VB plus that, okay? Then let's see. So this 340 is going to cancel with that 340. Then 21, that is going to be different. Let me move everything out to the left or to the right. So I'm going to have 2 VB squared. Okay. And when I move this on that side, it's going to be negative 2 to 100 minus 21 to 50. It's going to be minus 43350. Then when I subtract that, 7514. Okay. So is equal to this. So when I solve this, the end of the day, I'm getting my VB to be 6.8 meters per second. Guys, please help me with what you got in that kind of regard, okay? Then question number 7, they're telling us that a small negative charge Q placed at a fixed distance from charged sphere R experiences this kind of force as shown in the diagram. So if the force is moving towards Q, okay, meaning that there's some bit of attraction in this case, meaning that this must move. And since this is negative, then automatically this must be positive. They want us to draw the electric field around the positive. So something like that. Okay, field lines must be moving out. Then 7.2, there is sphere S that is attached to a ceiling, and we have all that information. State Coulomb's law. So Coulomb's law simply tells us that the electrostatic force, okay, between point charges is directly proportional to the product, okay, to the product of the charges, okay, and then inversely proportional to the square of the distance between them. That is what we have there, okay? Then 7.2.2, draw a free body that is looking at S, okay? So with S, we're gonna have one, the weight. We're gonna have the tension, and then we're gonna have the Coulomb's force there, the force that is as a result of R. All right, then they're telling us that sphere S is positive 6 nanocoulomb, that is R, and then S is 3 nanocoulomb, and then the mass is 0.15. Calculate the angle, theta. So for us to get the angle, okay, we need to know that this body S is going to experience this force. So let's first calculate the force, which means it's a K multiplied by Q1, Q2 over R squared. So 9 times 10 to the 9 multiplied by 6 times 10 to the negative 9 times 3 times 10 to the negative 9. I'm dividing this by 0.03 squared. This is giving me an answer of 0.00018. Okay, so that is more like the force that we are having. Okay, then if I'm to break this down, we know that there's going to be a component here. If this is a theta, meaning that that must also be a theta. So this is going to be a T, cos of theta. And then this is going to be the weight. So we know that T cos theta is equal to the weight. And then meaning that T is going to be the weight over the cos theta, which weight is like, we had 0.15. We change this to kilograms, you divide by 1,000. Okay, let's see. 0.15 divided by 1,000, we're getting 0.00015 times 9.8 over cos theta. This is my T. Then I know that this force here will be having the component, the horizontal component here, which is the T sine of theta. Okay, so T sine of theta, I'll equate it to my weight there, which is 0.00018. Then where there is T, I can replace it with this whole thing. Meaning that I'm gonna have a 0.00015 multiplied by 9.8, okay, over cos of theta. I'm multiplying by the sine of theta, should give me 0.00018. You can use your simplified decimals or exponents, and then you're good to go. Then I'm gonna divide this thing on this other side, okay? And we see what we end up with. So we know that sine over cos, that's gonna give us the tan of theta. 0.00018 divided by 0.12315 times 9.8. Let me put this in brackets, nice. Okay, so if I put in the brackets, I'm getting 0.12245. Okay, then the shift tan of this is giving me 6, okay, I'm saying shift tan of the answer, I'm getting 6.98, which is approximately like 7 degrees. Okay, so that is your theta that they need. Then question 8, they're telling us that in a circuit diagram below, the battery has an EMF of 24, the internal resistance is that, and we have all those resistors. Can we state Ohm's law in words? So we know that the current, okay, through a conductor, current through a conductor is directly proportional to the potential distance, or some people call it the voltage across, okay, across a conductor at a constant temperature. Then when both switches are closed, they want us to get the current through L. Where is L? This is L. But then they're telling us that the reading here is 0.8. So if we have this current, we have this resistance, we can get the voltage here. Okay, so I'm gonna say that the voltage is gonna be 0.8 multiplied by 13 from our Ohm's law. So this gives me a 10.4 volts. Now we know that since this resistor, this and this, they are all in parallel, the voltage is going to be the same. So the voltage or the current from this formula, we know that current will be voltage over the resistance, meaning that 10.4 divided by 9.5 must give me 1.09 amps. They want the reading of A2, so A2 is like the total current through the circuit. So I have the current here as 1.09. I have the current as 0.8. I need to find the current here. Okay, so still the voltage is the same even for the 9. So I'm gonna say that voltage in the 9 is gonna be, no, I'm not saying the voltage, I'm saying the current in the 9. Okay, current is in 9 is gonna be 10.4 over the resistance, which is 9, and that gives me 1.16 amps, meaning that the total current that we're gonna have should be 1.16 plus 1,09 plus the 0,8. And this must give us a 3,05 amps. And then they want us to get the total resistance R. Now, since these three are in parallel, I need to find the effective resistance of this parallel combination. Okay. So I'll say that the parallel, R of the parallel is going to be 1 over R1 plus 1 over R2 plus 1 over R3. It's going to be 1 over 9,5, 1 over 13 plus 1 over 9. Okay, so when I flip it around and find my R of parallel, this is going to give me 3,4 amps. Okay, if that is true, then I can use the EMF formula and say that my EMF is current into the R external plus the internal resistance. Now this R parallel will be in series with the R of interest. So this is going to be a 24 is equal to 3,05 into R plus the 3,41, now plus my internal resistance, which is 0,3. I'll start by dividing both sides by 3,05. So 24 divided by 3,05, that's going to give me a 7,869. I'm subtracting 3,41, I'm subtracting 0,3 to get my R, meaning that my R is 4,16 ohms. This is what I'm getting. Please, you can tell us what you got there. Then they're telling us that switch S2 is now opened, okay? So if S2 is opened, meaning that the current will just bypass L and then just complete the circuit. So this 13 and the 9 is out. Now, if that happens, how will this affect the reading of the A2? So how does the current go via that? So we know that initially when the two switches are closed, our effective resistance is going to be 7, something, because we have this 4,16. Now we're creating it, so we have 7,8 as our total resistance there. Now, when we remove those two, the resistance is going to increase, okay? When the resistance increases, the current must decrease. So we're going to say it's going to, how will this affect the reading? Okay, so we're saying the reading is going to decrease. The reading, the current reading in the ammeter is going to decrease. Okay, that it decreases. The reason, because of the increase in the resistor, in the resistance. Then how will the brightness be affected? We must choose increase, decrease. So now when the resistance is decreasing the resistance, né? How is that so? Because now look, let's look at this. If we are having just these two, this and that, we're going to have a total of 13, something, meaning that the resistance increased. If the resistance increased, the current must decrease. And how does this affect the brightness? The brightness will definitely decrease. Reason, we know that power is directly proportional to the current, okay? We can see that power increases, power decreases, okay? The power decreases. As the power decreases, there will be less current, okay? And then the brightness will also be less. Then we have letters A to F. So they want us to look at S1 being opened and S2 is closed. So this one is open, this one is closed. So the circuit is not complete. So, okay. So if it's not complete, which quantities will be equal to 0? That is the current, which is C. Okay, then question number 9, they're telling us we have an AC generator. Which polarity? So using the right-hand rule, the polarity of A is basically the north. State one way in which the induced EMF of this generator can be increased. You basically need to increase, okay, the number of turns. the number of turns of the coil, okay? You need to increase the magnetic strength. Okay, you need to use a stronger magnet. That's what we're meaning. You must increase the speed of rotation and so on and so forth. Then they want us to sketch the graph. So the graph is going to be simply something like that. Okay, this is time in seconds, and then this is the induced EMF. Okay, then 9.2. We have an AC generator that produces maximum voltage. Okay, so Vmax is 340. We have the power of 1.2. Define the term root mean square. So we know that root mean square is basically the equivalent constant current, okay, that would offer the same power to a resistor as the actual one, okay? So we just need to write that definition. The 9.2, they want us to calculate the root mean square current that is passing through. So what I'm gonna do, I will use the P average being the V RMS multiplied by the I RMS. But will this make sense? Yes, we have the power, which is 1.2. For us to get the V RMS, we must get the V max, we divide it by the square root of 2. So this is 340 over the square root of 2 times the I RMS. When you do your magic and push everything that side, the I RMS that I'm ending up with is a 4,99 amps. Okay, 4,99 amps. Then they want us to get the resistance within the kettle. So you can say resistance is V squared over R, meaning that the R is gonna be V squared over the power. Now we know that our V squared, we're looking at the V RMS, okay, which is a 340 over square root of 2. This is squared. We're dividing it by 1.2, meaning that that resistance of ours is more like a 48,17 ohms. Okay, so that is what I would have done with question number 9. And then question number 10, they are telling us light of different frequencies is incident on a metal plane. The sketch below shows the relationship between the maximum kinetic energy of the photoelectrons and the energy that will be incident. Define the term work function. So work function is more like the minimum energy required. Okay, minimum energy required to remove an electron. To remove an electron from the metal surface. From the metal surface. Now they're asking us to write the numerical value of the gradient. So what's happening here with the gradient? The energy of the photons and the EK max. So EK max over the energy of the electrons. Which constant is that? It's the numerical value. Anybody to help us? What we have there? EK max, the constant is gonna be, I'll write the Planck's constant here. Okay, because that's more like the gradient that I can only think of whenever I have graphs of this. And we know that Planck's constant will be 6,63 times 10 to the negative 34 joules second. Then they want us to calculate the maximum speed of the photoelectrons when photons with energy Y, as shown, strike the metal plate. So we know that the energy, the EK max is 2,99. They want us to get what? The maximum speed. So let's just put it aside. That is 10.3.1. Okay, so 10.3.1, what I'll do is I know that my EK max is given as a half mv squared. That's 2,99 times 10 to the negative 19 is equal to a half. The mass of an electron is 9,11 times 10 to the negative 31 v squared. Do your magic. Okay, if I do my magic, I'm ending up with a v of 8,1 times 10 to the 5 meters per second. And then 10.3.2, they want us to get the value of y. So what is the energy of the photons? Now we know that this is the work function. Okay, that is our W naught, the work function that we have. So the formula that combines work function and EK max, do we have anything like that? Yes. So we could use something like seeing a formula here that says that E is equivalent to W naught plus EK max, EK kinetic, maximum kinetic energy. Now, the energy that we need is what we are calling the Y. I don't know why this question is from us, unless if I'm getting it wrong. Okay. Do we need the frequency? The frequency, that's going to take us some other time. Okay, so what I'm going to do, I'm just going to add the two, whatever the two values. So it's going to be 3,68 times 10 to the negative 19 plus my energy, my EK max is 2,99 times 10 to the negative 19. So 3,68 plus 2,99, that gives me 6,67 times 10 to the negative 19 joules. So that's what I'm getting then. Then 10.4, they're telling us we have photons of this much energy that are striking the metal plate, or okay. Then the number of these photons with this type of energy is increased. Okay, how the maximum kinetic energy be affected? So this is more like when you increase the number of electrons, you're basically increasing the intensity. So how does intensity affect the kinetic energy? So in this case, it's just gonna remain the same. Okay, so what is the explanation? We know that intensity, okay, does not increase. Okay, we can say that intensity, yes, it increases the number, okay, of electrons, but not the energy, not the energy. All right, guys, so that is that with the paper, and I can maybe see out of 100, it was something like 95% doable, okay? So guys, that's where we stop. I wish you all the best, and as you prepare for your paper too. Okay, let's meet then. Bye-bye for now. Hello, welcome to yet this episode where we shall be looking at the proposed memorandum for the Physical Sciences Paper 1, grade 12, May, June 2025. Okay, so in this paper, we have 10 questions that we shall be looking at, and we shall be exploring, okay? So with question number 1, which is the multiple choice, they're telling us that we have 4 options and we must choose the most correct option. Now we have 3 forces that are acting, okay, on an object as shown, so that the resultant force is what? 0. So each of the following vector diagrams is correct representation.